We think that the universe was probably born in something we call the Big Bang, but it's not a bang in the sense of an explosion with bits flying out all over the place. It's more of an expansion, an inflation. We can describe it a bit like a balloon. You've got lots and lots of matter and energy, and then something happened, we don't know what, that made it inflate. And then the galaxies that we see in this picture are a bit like the dots on this balloon, and they're still expanding away from each other. And we can see that when we look out in the universe today.
So how do we know that the universe is expanding? We found out what was in the sun by looking at its spectrum. But the light from stars and galaxies tells us more than just what the stars are made of. It also tells us that they are moving away from us. This is the spectrum of a galaxy. It has lines like the sun. This is a spectrum of a near galaxy. It tells us that the element calcium is present. It's in black and white to make the lines show up better. This next spectrum of a galaxy that is further away from us also shows that calcium is present. But the calcium lines have moved. They should be here. And the third spectrum is from a galaxy that is even further away. Again, the calcium lines have moved further right. This is called red shift, because the lines have shifted towards the red end of the spectrum. So what causes red shift? Imagine an alien spaceship is traveling very fast. It's approaching the speed of light. As it travels towards us, it looks blue. As it travels away from us, it looks red. All objects traveling towards us at high speed look blue. All objects traveling away from us look red. So, if our calcium lines have moved to the red end of the spectrum, the galaxies must be moving away from us.
So the lines in the spectra of these galaxies are moving from the blue end of the spectrum towards the red end of the spectrum, this red shift. And if that's the case, the only way we know to explain that is that the space between these galaxies must be expanding. They must be moving apart. And this is evidence that the universe is indeed expanding and getting larger. Well, if it's expanding, does that mean that a long time ago it was much smaller than it is today? This noise is the cosmic background radiation. It's just a faint hiss now in the universe, but we think it's the echo of the unimaginable fireball that probably was the Big Bang. The Big Bang, this hiss left over, is probably the most conclusive piece of evidence we have that once upon a time the universe did start with this amazing cataclysm.
If the universe was born from an unimaginably hot, bright flash to create stars, galaxies and planets, the energy from the flash must still be around us. We can't see it, because after about 12,000 million years the light has dimmed. But we can detect it with radio telescopes. This signal is what is left over from the Big Bang, and this is a computer image of these signals. No other theory can explain this cosmic background radiation. And if the stars were formed in this cataclysmic explosion, the galaxies must still be expanding outwards at some phenomenal speed. Evidence for this comes from red shift. Objects traveling away from us look red. Light from very distant galaxies is red shifted.
At the moment, we cannot be 100% sure that the Big Bang actually did happen. All the evidence points to it, but the only way we'd ever know for sure would be to go back and witness it.
Who knows? The next generation of Hubble telescopes, built in the 21st century, may be able to look even further back in space and time, to witness the universe in its early throes of creation.